Mr. Clown here, Clown Maths. Today we're going to be looking at the determinant of a 3x3 matrix. Let's just jump straight into this. So, if we have got a 3x3 matrix here, to find the determinant, what you do is you do the first element A times the determinant of this 2x2 matrix. Now how you get that is you delete the column and the row that is in A. So I'm deleting this column and this row, like so, and that leaves me with E, F, H, and I. So it's A times E, F, H, and I. I then move on to my next element and it becomes minus. So it's minus B times, and I delete the column and the row. So I'm left with E, D, F, G, I. So minus B times D, F, G, I. Deleting the column and the row. And then it's back to plus. So it's plus C. Delete the column that's in and the row. So that leaves me with the matrix D, E, G, H. D, E, G, H times C. And it's just something that in advanced higher level you're just going to have to remember. But let's go into an example of how to actually do this with the determinant of this matrix here. So we've got 3 times, delete the row and the column it's in 3. So I've got 2, 5, 4, 3. Then minus 1 times, delete the row and the column. So that leaves me with 2, 5, minus 3, 3, plus 4 times. And again, I'm going to delete the row and the column. That gives me 2, 2, minus 3, 4. So I need to work out all my individual determinants. So that's 3 times 2 times 3 minus 5 times 4. Take away 1 times 2 times 3 minus 5 times minus 3 plus 4, 2 times 4 minus 2 times minus 3. So that's 3 times minus 14 minus 1 times 21 plus 4 times 14. So that equals 3 times minus 14 plus 4, so that's 14, take away 21, minus 7. And you can use a calculator if you need to at any point. Okay, so find the determinant of this matrix. So we've got 1 times the determinant, 5 minus 6, 8, 2, minus 2 times the determinant, deleting the rows and columns, we get 4 minus 6, minus 1, 2, plus 0 times the determinant, 4, 5, minus 1, 8. So working some of that out, we've got 1 times 5 times 2 minus 6 times 8. Take away 2 times 4 times 2 minus 6 times minus 1. And then we've obviously got plus nothing, so we'll just leave that, that'll give us nothing. So working that out, which is 58. So take away 4, and we get 54. A is this matrix, and since it is singular, find the possible values of K. So singular, that, remember, means the determinant equals 0. We've got 3 times 1, 2, 0, k add 3 minus k times minus 2, 2, 5, k add 3 plus 0 times minus 2, 1, 5, 0. 3 times k plus 3 and 2 times nothing is nothing minus k times. So we've got minus 2 times k add 3, so that's minus 2k minus 6. Take away 10. And then we've got add nothing. So that implies we've got 3k plus 9 plus 2k squared plus 16k, and that equals 0. So we've got 2k squared plus 19k plus 9 equals 0, double brackets, equals 0, 2k and k. So that gives us k equals minus a half, or k equals minus 9. And we're done. So this comes from the 2016 specimen paper, question 7. Find the values of k for which this is singular. So remember, once again, singular implies the determinant of, let's call it matrix A, equals nothing. 3 times minus 4, 2, 0, 1. Take away k times 3, 2, k, 1. Plus 2 times 3 minus 4, k, 0. And we're going to say that equals nothing. So that gives us 3 times minus 4, so that's minus 12 for the first element. 3 times 1 is 3, times k, so minus 3k. Take away 2k times minus k, so plus 2k squared. That's 0. Take away negative 4k, so positive 4k times 2 is plus 8k. And that equals 0. 2k squared plus 5k minus 12 equals 0. Double brackets. 2k and k. So k equals 3 over 2, or k equals negative 4. So a few properties of determinants that you should be aware of. If you take the determinant of a times b, then it's the same as doing the determinant of a times the determinant of b separately. If you times your matrix by a scalar and you go to the determinant of that, then it's the same as doing that scalar to the power of n times the determinant of a. And that's assuming that a has an order of n times n. So for a 2 by 2 matrix, it would be k squared. For a 3 by 3 matrix, it would be k cubed. And the last property you should be aware of, the determinant of the transpose of A is just equal to the determinant of A. Transposing the matrix makes no difference to the determinant.